Recording now. Yeah.
We haven't got any recording yet. Can you please talk to training desk and ask them to send us the recording?
Sure. Give me 1 second of time. I would like to give you that, all playlist recording access. So who are not, so Canvas instructor login. So, okay. So this is the machine learning, right? For machine learning, this is yesterday class recording. If you click on it, you will able to get that recording here itself. Okay. You know,
Can you please send us the link as well?
Sure, I'm directly giving that playlist access for you all. Okay, so let me check your mail IDs in my. Okay, so one after one. Okay, first.
I'm
Okay,
typing my mail ID in the chat.
okay, so Sweta. Is it correct, Sweta? So
Yes, sir.
Sweta, morning I have given access for SQL and Tableau. Did you receive it or not?
No, sir, not yet.
Okay, can you please check your mail ID and you will get that link from the Canvas invitation.
No, sir.
Please check your mail ID in a spam at least.
Yeah, yeah. Canva. Okay, Canvas free.
Yes, that's what.
I
Oh,
haven't received it.
So definitely everyone can able to receive that invitation from the Canvas and click on the get started and set your own password and whatever the mail ID you mention and whatever the password you are considered it. So you should remember those two things and every time you should go with canvas.instructor.com and you can log in with your mail ID and your password. Okay, automatically the recordings could be uploaded in that particular playlist itself. How many playlists you get an access that all could be available in your student LMS. Clear?
So would you be able
Yeah,
to add my email ID? I
You
think.
don't need to add your email ID. You already
Okay.
given email
Oh,
ID.
okay.
You just
Got it.
set your own password.
Okay. Yeah.
but I haven't received the email though.
So your
Samir, I haven't received.
so guys, I'm not given some
I
access to you all. Only few people got the access as of now.
My email is bazingacoolguy@gmail.com. BAZINGACOOLGUY@gmail.com. You can put in there.
No problem.
so I got it.
So So Aravindo, can you please share me your mail ID?
It's not 2Gs, it's 1G. You have to delete that 1G and just have 1G. And then GUY at gmail.com
Okay.
for
Mine is
all the
arbindo
things.
at hotmail.com.
Okay. Sweta, Sahil, and Ashif, and only five. What about others?
Mine is arbindo@hotmail.com, Anjan.
Okay. Can you send in the chat of Zoom? Ravindo, can you please send me your mail ID in the chat?
Yeah, it's my first name at hotmail.com, but I can.
This is for the data science recording only, right?
This is it's a data science which is having the multiple models within that one machine learning. Only machine learning recordings will get in the machine learning playlist. Okay.
You mentioned something about Tableau or something.
Yeah. So if you're attending the sessions of Tableau, then you will be getting the Tableau recordings as well. I will message you. I will call you. Okay, just wait for 1 minute. Arvindo, I'm not received it. I'm writing your mail ID. Please, we check it whether it is correct or not.
EOO@hotmail.com. Yeah, you got it.
Just only name.
Yeah.
@
Hotmail.
Hotmail.
No, Hotmail. HOT.
Hotmail.com. Okay. Okay. Back. I can copy. Yes. Set your names. Shali Shaker means, is it Sami? Okay. May I know Shalini, right?
Yeah, that's Shalini. Yeah.
Okay, Ashif and Akash. And
No, the second A has to be lowercase,
just
not AK. It has to be AA. The second A before the K has to be lowercase. It's wrong.
whatever it is, no problem, Akash. It's just names. Okay, yep. Okay, so you all get that, invitations from the canvas, and please go and click on get started and accept the invitation, and then you can set your own password. If you have already, if you have an account, then you can log in. If you don't have an account, you have to create it. Okay. In the meanwhile, I would like to give the access for the Python sessions. Who are attending the Python sessions, and so those guys also I'm giving access for that one. Okay, so Aravindo, this time you are not attending the Python sessions, right? So it's fine, done. So Sweta, are you attending that Python sessions?
Yes, sir.
Samir,
I'm not attending.
no problem, you can attend if you want it. Shalini, Shif, and Akash, and Samir. So you will get that invitation of Python as well. Okay. So multiple invitations you are getting, so you should accept that all things. Don't delay. Don't deny. We're attending that SQL classes. So I would like to give it SQL things. Shalini, are you attending?
No, I'm not. No, I'm not actually attending SQL. So you can.
So try to be attend if possible. Time is not
Yeah.
consistent.
I'm looking forward to your statistics, and I was actually asking about deep learning and NLP. I mean,
That
I
I
had
will
some.
talk, after completion of
Okay.
all things. It's not much important for you all, okay? But yeah, if time comes, definitely will.
Holding.
Yeah, so who are enrolling for, artificial intelligence, those guys will able to go
I
for.
don't have the details for the sequel class. I don't know what time the sequel
Yeah,
class is.
even I don't know what timing you have it, so maybe I'll check with you.
Okay, so I would like to give it multiple timings. Just one second. Who is that? Arvindo, is it you?
What's that?
Someone is talking about some
That
paper.
was, I think that was Asif.
Okay. Ashif,
Yeah, I was
you're not aware of SQL timings?
no, I'm not. Or the Tableau.
Okay, so it could be morning sessions.
Morning I cannot attend.
Okay, that's what you're not okay. Running those things. If possible, you can try to be attend, or else go for recording. Okay, if everything is fine, that's okay. If you're not fine, then I can invite you in new meetings. Okay. Okay. Yep. I given enough. I gave that all current running models of data science related thing, and hopefully you can log in and that Canvas playlist and accept that invitation from the Canvas and set your own password, and then after you will get that this kind of things in our playlist. Okay. Is there anyone is facing to access that recordings? Is there anyone facing an issue by the time of accessing the recordings?
I haven't checked, I will check.
Can you please check your mail IDs? Okay. So this time I would like to talk about linear regression concepts. So what exactly the linear regression and the thing I would like to go for explain, and the corresponding document also I can provide you. Okay. So let's talk about linear regression. Guys, you will get this kind of document. Okay, you will get this document, you don't worry about it. Okay, so let's talk about linear regression. This is the one of the supervised machine learning algorithm. So what exactly that linear regression? Okay, the mathematics behind the linear regression is based on the concept of finding the best fitting line through a set of data points. Okay, this could be the equation. You might be thinking what exactly this one, right? Okay, for that one I would like to go for explaining in detailly. Okay, just wait for, I'm opening my whiteboard. So let's talk about linear regression, right? So I just want to give it some few information so that it will be easy to understand the document. Otherwise the document, it could be tough to understand again. Okay. Yep. So let me consider you have some kind of historical data. Okay. The historical data which we have the, okay, different variables we have it. Let me consider I have the only one variable, one input variable, and I have one output variable. Okay. So this time the output variable which is depending on the input variable. Okay. So the dependent or the relation between these two things, guys, can you please meet our systems? So the dependence of this output variable in the on the input variable, there different kind of relations we have it. Okay. For example, if x is increasing, maybe the y also can be increased. This could be the one relation, right? Okay. For example, if x is increasing, even though the y it could be increases, this is another relation. Okay. So when x is increases, y also increases, this kind of relation is, it's a positive relation. Okay, linear relation. Actually linear means there could be some kind of linearness between the two variables. For example, in between the x and y there could be some kind of linear regression with a positive sign, then it could be positive linear relation. Okay. For example, if x is increases, then y could be decreases. This kind of relation we are calling it a negative relationship. Okay. So if we have only one input, we have only one dependent variable and we have only one independent variable, then you would like to go for using the simple linear regression. Simple linear regression. Okay, for example, you have the multiple independent variables, for example x1, x2 and x3. In this particular situation, the y, it was depending on the x3, the y which is depending on the x2, the y which is depending on the x1. So this kind of linearness, we are calling it, say, multiple linear regression. When we have the multiple independent variable with one dependent variable, that situation we would like to go for using the multiple linear regression. Okay, I hope you understood what is the difference between the simple linear regression and multiple linear regression. Simple linear regression, we have only one independent variable, then it could be simple linear regression. And moreover, the dependent variable, with the relationship between the dependent variable and independent variable, it could be some kind of linearness. It may be positive linearness or else negative linearness. Whatever it is, it could be some, it might having some kind of linear relationship. Clear? Now, our aim is that, for example, if it is the linear relationship, it might be positive or negative. So I want to be find this best fit line, okay, with multiple observations. Again, for understanding of this one, let me consider I have the one independent variable, I have one dependent variable. Okay, here we have some kind of data points. Okay, here we have some kind of data points. Okay, so now what I can do, I can plot this x corresponding y. I want to plot the y values corresponding x value. Okay, this is my data points. Let me consider this is my data points. This is the data points actually. Okay, so what I want to do actually, I would like to be finding the best fit line. It might be this line, it might be this line, it might be this line, it might be this line. There could be a lot of linear lines, right? It may be passing through this particular data points only, right? Okay, is it clear or not? So our aim is that I would like to go for finding the best fit line among this all lines. Among these all linear lines, I would like to go for finding the best fit linear line. I hope you clear my point. Any
Yes,
question?
clear to me.
Yeah, when we have some kind of relationship between the x and y, dependent variable and independent variable, okay, there could be a lot of linear equations you can able to get it. But from that all linear equations, you would like to go for finding the best linear equation or best linear line. Okay, see, you can go ahead, you can consider any linear equation. Let me consider this is my x and this is my y. Okay, let me consider if you can consider the line. So this line you can represent it with y equal to mx plus c or else mx plus b. It can be anything. Okay, or else if you considering this line, so even this is also linear line only, right? So the linear, in the sense, the linear equation, it could be this particular format only, y equal to mx plus c or y equal to mx plus b, whatever it is. Clear? So guys, but out of this all, I want to find the best fit line. That means best m value and b values, best m values and b values. Okay, so for more understanding purpose, then what I can do, I can plot the multiple linear equations. So for example, this is my x and this is my y. Okay, I have the linear equation 1. So if I find the linear equation, then it could be y equal to m1 x plus b, because of here x values and the y values could be a constant. It was available in our data set only, right? So here m1 and b1, so here m1 and b1, it could be different values. So you have to, these are the coefficients actually. For example, if I considering the another line, this is my second line. Okay, if it is this line, then y equal to m2 x plus b1. For example, if I'm considering this line, this is also linear line, right? So this linear line you can represent it with y equal to m3 x plus b3. Okay, so here M3, M1, M2 are the slope values, right? See, these are all different kind of equations we are getting. The reason is that we have a lot of data points are there. So this all data points could be available on your plane or on your graph only. Okay, so you are able to go for find the best fit line for that one for estimation of this m and b values. So you would like to go for finding the best m value and the b values. For that one we would like to go for using the least square methods. Least square method. Okay, so the least square method, it will give you the best parameters. Okay, best parameters in the sense you can directly finding the m value and b value. Those are your best values. So how you can able to know that these are the best values? See, let me consider you have some kind of actual data. Okay, you have some kind of actual data, so you are predicted line, right? So that your predicted values. Okay, the difference between the predicted and actual, that we are calling it say residuals. What is mean that residual means a difference between actual and predicted, that we are calling it say residual. So how the least square method, what is the importance of the least square method, and how you can able to find the best parameters? Okay, see, there could be some kind of cost function, or else we can call it a loss function. Okay, the loss function or cost function, the loss function and cost function, it could be error. It means that it could be error. Okay, our aim is that, so our actual and your predicted, when you do that difference, okay, it could be approximately equal to 0. It could be equal to it could be approximately equal to 0. Okay, for that one, for initial values of m and m value and b value, maybe you have actual and predicted value. Okay, there could be some kind of lot of difference actually. Okay, our aim is that we should minimizing the cost. You should go for minimizing the cost function or else loss function. So how you can do that? With the help of the least square method. Okay, here cost function we can represent it with 1 by some n value. Okay, sum of it's your y values minus it's your predicted y hat, in the sense it's your predicted value. Okay, then we can do that a square actually. So this is your cost function. So this is the value, it will give you error term. Okay, hopefully what you should do actually, you should reduce the error value. So that we will do with the help of the least square method. Okay, now we can see the document, it will easy to understood actually, otherwise it's not possible. So let's read one by one. The mathematical behind the linear regression is based on the concept of finding the best fitting line through the set of data points. So set of data points in the sense you have some kind of historical data. So those are your set of data points actually. From that one, and which is the best fit line which is passing through those particular data points actually. Okay, that equation we are representing with y equal to mx plus c. Your y indicating that it's your dependent variable, x indicating that it's your independent variable, m indicating that it's your slope, and b indicating that it's your intercept value. Okay, intercept in the sense which is touching the y line. Okay, so in linear equation we aim to finding the value of m and b. Okay, so why we should go for finding the m and b? So if you don't have the m value and b value, then how we can able to predict the y predictions with the help of some x values? Okay, so that we would like to go for finding the m value and b value, that minimizing the difference between the predicted values and your actual values. So predicted values in the sense, after you creating the model, if you are giving some new data or existing data, you will get some kind of output value. So your original y value and the original actual value and your predicted value, you should do the difference actually. Okay, the difference we should minimize it. Okay, the difference is measured using the loss function or else a cost function. So most common method is mean square error. So MSE is the one of the cost function. You have a lot of cost functions are there, like mean absolute error, root mean square error, mean square error. These are all cost functions only. Okay, this is the most common method. Mean square error is the one of the most common cost function or loss function. Okay, to determining the best fit line, we use that we use a method. That method we are calling it say least square method. So with help of this least square method, we can minimizing the sum of squares of difference between the actual and predicted value. That's what I am trying to tell you, right? This is the cost function, some square difference between the predicted and this is the thing only, right? Okay, it's a sum difference between the actual. This is y I means its actual value, y hat in the sense it's our predicted value. The difference between the y hat, y value, actual and predicted value, and we can do the square and we can do the sum actually. Okay, so that it could be your, so you should minimize that particular cost value. Okay, cost function. Okay, so the value of m and b, that minimizing the sum of the values of the best fit data, the equation can be calculated with the slope value of m and y. Slope is m and intercept value is the b actually. Okay, you just see this particular graph. So this graph which we have the blue color dots, right, scatter points, right, those are your observed values. Those are your original values. Okay, those are your original values. Okay, just consider here. Okay, this blue color lines are the your observed values, your actual data. Okay, now this is the line, right? This is your line. This is line, we are calling it say linear line. Okay, this linear line, you can take that any slope value. Okay, if you change any value in an independent variable, if you change one unit in input variable, the change will happening in y as well. Okay, change in input y changes changes x and change in y, right? So this value we can able to calculate it, that we are calling it a slope. The slope value, finding the slope value, this is the function we can use it. This is the formula. Okay, the formula, it could help you to finding that slope value with help of the least square method. This is the least square method. With help of the least square method, we are finding the m value. This is the equation of m value. We have to substitute this all values, then you will be getting the m value. Okay, after you getting the m value, then you can use this particular formula, then you will be getting the b value as well. Okay, so for finding the m value and b value, we have a formula. Now we have to try to be understood the difference between the this actual and this is your predictor point. Okay, this is your actual. So the difference between these two things, we are calling it say residual. Okay, so this is the point. Okay, residual, and this is the point residual. This is the point is residual. The difference between the actual and predicted value, that we are calling it say residual. Okay, our aim is that we should minimize the difference. Our aim is that we should minimize as much of as possible. You can reduce this particular distance. Okay,
Thing.
you should minimize the error between the actual and predicted value. Okay, so when we can do that, when we have a best m value and b value, then only you can able to minimize the error. Okay, so for finding that best m value and b value, this is the formula, you should go for use it. So n is nothing but for total number of samples. Okay, and x is your input value, y is your output value. That means independent value and output dependent and independent. So those two things we can multiply and then we can do the sum, which means that, for example, so the data which we have something like this: 1, 2, 4, 4 and 5. This is 6 and 7, right? This is x and this is y. Then what we can do? We can do that sum, right? Sum in the sense, so multiplication of these two things. Okay, so 1 into 2, 2, plus 4 into 5, it's a 20, plus 6 into 7, it could be 42, right? So this is the way we can do that sum. Here total we have a 3 elements, right? So that 3 into okay, and minus sum of y. Sum of y in the sense we can do that sum of this all 2 plus 5 plus 7, it's a 14, right? And the sum of x in the sense 1 plus 4 plus 6, 1 plus 4 it's a 5 plus 6 it's 11, okay, into 11. So this is the 4 into 11, okay. Meanwhile, so n into sum of squares, right? So this is your x value. So 1 square it's a 1, and 4 square it's a 16, and 6 square it's a 36. So what you should do, we can sum of this all values, okay. Meanwhile, sum of x in the sense this is 1 plus 5, 1 plus 4 plus 6 it's 11, 11 square, okay. So this is the values you should substitute, and you will be getting the m value, and you will be getting the b value. So to finding the b value, we can go ahead with your actual sum value of y, and then you have already calculated the m value, and we can have the x data, and you know that how many number of samples we have it. So based upon this function and based upon these formulas, we can easily calculating the m value and b values, okay. Again, we easily calculating the m value and b value. So once if you're calculating the m value and b value, then we can able to go for substitute. So this m value and b value we can substitute in this particular formula. So this is the y is nothing but your predicted value, and m is your calculated value. This x is for new inputs. If any new inputs, you will be getting the new outputs actually. This m and b, it could be constant, this could be coefficients, we already calculated with help of this particular formula. For any new x value, you will be getting the corresponding y value, right? So this is the way you can able to go for do that finding the best fit line. Now let's we have some example, okay. We can say let's say we want to model the relationship between the number of hours studied and the score on the exam. For example, one student is spending for studies 5 hours in a daily, and then he is getting some score, okay. So there could be some kind of relation, right? If students are studying more, then they will be getting the score high, right? Okay. So that so there could be some kind of linearness. So this is my x values 5, 7, 3 hours and 8 hours. If the students are studying more hours, then they are getting the high score. Here the data, it could be very small, then we can easily understand. But if we have a large data, then what we can do? So this, with help of these values, now what we can do, we are going to be calculating the m value, okay. We are going to be calculating the m value, okay. This is your m value, and this is your b value. So how you're calculating the m value and b value? You already know that the formula of m, and you already know that the formula of b. So if you're calculating the m value and if you're calculating the b value, then you can substitute in this particular equation. This is the best fit equation or best fit line. This is the line, it can help you to find the any new input. If I'm giving, then you will be getting the some new output actually, okay. Clear?
Yeah.
Yes.
Just 1 second. Okay, so this is the equation. It can help you to find the exam score if you studied some number of hours. Okay, so this, it could be help you, when we are doing that linear regression or multiple linear regression or simple linear regression, whatever it is. Okay, we have some kind of assumptions actually. What are the assumptions? The first assumption is linearity. Okay, second assumption is independentness, and third assumption is homoscedasticity, and fourth one is normality, and fifth one is no multicollinearity. Okay, so this is a very, very important question. So if you're attending that machine learning interview, okay, if you're already having an experience in linear regression or multiple linear regression, so this is the question you might be getting. What is the assumptions of the linear regression? Okay, the first assumption is linearity. Linearity in the sense, the relationship between the independent and dependent variable should be linear. Okay, how you can able to say that independent variable which is linear with a dependent variable? So for that one, we have a technique which is a scatter plot. Okay, so in Python we have a matplotlib. Inside of the matplotlib we have a function, a scatter function we have it. Okay, so with the help of that particular function, plot function, we have it. With the help of the plot function, we can able to plot the scatter plot. Okay, I will show you practically, don't worry. But scatter plot is the one of the best method. This is one of the visualization technique. With the help of this one, we can able to finding the linear relationship between the independent and the dependent variable. Okay, and second one is, additionally, we can use the measure of association such as the correlation coefficient. So covariance and correlation coefficient, did you remember that one? So covariance, it could be giving that relation, whether it is a positive relation or negative relation, but how strongly those are correlated, if you want to know it, then we can use the correlation coefficient. So if you find the correlation coefficient between those two variables, independent and dependent variable, if it is giving the positive value, those two are strongly positive direction. Okay, if you are getting the negative value, then both are negatively strongly correlated. If you are getting the correlation coefficient nearly zero, that means the relationship between those two variables is no direction. Okay, meanwhile in Python we use the stats model API library. Within that one, we have the OLS method which can be obtain the correlation matrix, which can be used to check the correlation between the independent variable and dependent variable. These are the ways we can do this particular test actually. If you want to test the linearity of independent variable and dependent variable, so one is the scatter plot, second one is the correlation coefficient, and third one is the correlation matrix. Okay, so these are the different approaches we can go, and we can find the relationship between the independent variable and dependent variable. I hope you clear this assumption.
So would you, when you're doing the practical session, would you be showing us
Of
through
course,
each
I
of
can do.
those
I
linearity?
can.
Okay.
With
Thank you.
practically with a project from end to end, I will show you. Okay, don't worry about
Okay,
it.
thanks.
But when I'm directly going through this particular project, no, then you might be thinking why Amjan is doing linearity test, right? So that's a assess. This session, it's an explanation of the multiple linear regression. Tomorrow session, I can bring a project and I can do that each and everything. I will show you each and every assumption, validation techniques, building the model with the help of the Python programming language. Clear?
Yeah, thank you.
Okay, so the third one is independentness. So observations are independent to each other. For example, if we have one observation, it might be, it should be independent. That means there is no relationship between the observations. Okay, this assumption we can check by using the scatter plot. So here also we are going to be using the method is a scatter plot, right? But the scatter plot, what we are doing between the independent and dependent variable, right? But when it comes to the independentness, so the scatter plot of the residual, what is mean that residual? Residual means what? The difference between what? The difference between the actual and predicted, that we are calling it say residual. So the residual against the time in any other variable that may indicating that trend, and usually inspect the is there any pattern is there. Okay, so and second one is Darban-Watson test. So this is also interview questions, guys. How you can test the independentness? So by the time you can use this names, and we should do this particular test only. Darban-Watson test. So Darban-Watson test, it could be help you to check the is there any independentness or not. It should be independentness. Observations should be independent. Okay, and so if you want to test this one, in Python programming language, we have the stats model. Within that one, TSA and stats tool, we have it. Within that one, we have a method is Darban_Watson. This is the function. It will help you to test the Darban-Watson test. Okay. So what is the use of the Darban-Watson test? To check the independentness. And homoscedasticity. Homoscedasticity in the sense the variance of the errors is constant. So the variance of the errors, it should be constant. If it is not constant all levels, which means that it could be heteroscedasticity. Okay. So this assumption we can check with help of the scatter plot of the residual against the predicted values. Okay, you can have the residual values and we have the predicted values, right? You have to do that scatter plot between the residual and predicted values. Okay, so whether it is giving that which relation which is giving, whether it is a constant or else is there any changes will happening, we will able to look for that one. Okay, with help of visualization we can do this test, or else I want to test with Python code. For that one we can have the Burkowitz and Pagan test. Okay, Brecht-Pagan test.
Bruch-Pagan test.
Yes, Bruch-Pagan test.
Bruch-Pagan, yes.
Yes, or else white test. So you can go ahead with the white test or else Bruch-Pagan test. Okay, so these are very, very important tests actually. So if and only if whether we can go ahead with visualization and whether we can go ahead with which language we are working on it, that corresponding method we should use it actually. Okay, even if you are using the Python, then this is the test we should use it. Even if you are using the R language, so this is the test only we are going to be using, but corresponding that particular method or function which is available in that particular programming language. For example, if you are using the SPSS, in SPSS also we have this particular test related thing. Okay, so there might be some kind of option to test these things actually. But if it is
So that
Yeah.
that first line, right, and under homoscedasticity, which says variance of the errors. So
Yeah.
does that mean that the difference between the actual and the predicted, which is the y minus y hat, that difference among different
Yes, it could be
input
constant. Yes, it could be
should be
constant.
constant.
If you plot it, then it could be a line, it never increase or decrease actually. It could be somewhat same pattern. Okay, it could
I mean,
be same line.
between different examples or
Yes.
data points,
Yep.
they should be constant. Okay,
Yeah.
got it. Thanks.
So next one is normality. So if you go ahead with the residuals, okay, so that residual, the errors, it should be normally distributed. Normally distribution means what? If you plot the errors or if you plot the residuals, you'll be getting the curve something like this. Okay, so that we are calling it a normal distribution. So when you are plot the errors or when you distributed the errors or residuals, you will be getting the normally distributed. Okay, these assumptions we can do by creating the histogram. By creating the histogram of the residual, so when you're creating the histogram of residual, you will be getting this kind of thing, histogram, right? So you will be getting this kind of pattern. I will show you this everything in our project actually. Okay, this all test will work on it. And no multicollinearity. Multicollinearity in the sense, maybe if you have the multiple independent variables, so this all multiple independent variables should be no relation. Okay, so independent variables are not highly correlated each other. So the relationship between the independent variable versus independent variable, it should be no relation. Okay, this assumption we can check with help of the correlation matrix or else VIF, variance inflation factor. Okay, with help of the variance inflation factor, we will able to go for finding the is there any kind of multicollinearity. So make sure that no multicollinearity. These are the assumptions actually. Clear or not? Okay, these are the assumptions. These are the assumptions if you are getting the best linear regression model or not. If and only if all assumptions are satisfied, then only your linear regression is met your conditions. Otherwise, it could not giving that good response. Okay. So to evaluate the linear regression, whatever the linear regression we or whatever the best fit line you created, whether the best fit line, whether it is correct or not, whether if you want to be evaluated that particular linear regression model, then we have approximately 7 we have more other matrices we have it, but those are the most important matrices. So usually this is also one kind of interview question, how you can finalize the model. Actually most of the people, they are saying that I checked the accuracy, then it was good, then my model is good. So that's not a correct answer actually. Okay, so if you check that I just checked that mean square error, then it was giving that very less, then I confirming that the model is good. So this is answer is wrong. Okay, when you're evaluating the model, when you're evaluating or when you're validating or when you're finalizing the model, you're not depending on the one parameter, you're not depending on the one matrices. Okay, those are print there is a multiple or a couple of a couple of parameters we have it, like r square and adjusted r square and mean square error and root mean square error and absolute mean square error. Okay, and predictive power and AAC BAC values. Okay, so these are the things it can help you to evaluate the your linear regression model. Okay, if your r square is good, that means r square means coefficient of determination. Okay, r square means it's a coefficient of determination. What exactly the r square is talking? It will measuring the how well the model fit in the data, how well the model is fit in the data actually. Okay, it is a proportion of the variance in the dependent variable that is explained by the independent variable. Usually the r square value, the range it was starting from 0 to 1. The higher the I value, okay, 1 indicating that model is perfectly fit to the data values, 0 indicating that the model is not fitting with your data. Okay, does not fit with the data at all. So your adjusted r square, in the sense, let me consider you have the multiple independent variables are there. Okay, so out of this all multiple independent variables, some of the variables not impact on your dependent variable. If you remove this one, by the time, okay, and the adjust r square will help you. Okay, the adjust r square is modified version of the r square that adjusts the number of independent variable in the model. It is a better measure of the model performance when you're comparing the model with a different number of independent variables. Okay, so you are build the model with 10 independent variables and you build the model with 8 independent variables, then you can go ahead with compare the adjusted r square. Okay, if there is no change in adjusted r square, that means what, with lower the independent variables, which was giving the more accuracy. Okay, and mean square error, it could be your error term. Okay, mean square error is the measure of difference between the predicted and actual values. So predicted and actual values. So Pavani, can you please come to the session after 4 to 5 minutes?
Oh yeah, sorry.
Yeah. So mean square error and root mean square error. So whatever the mean square error, we have a formula that we just do that root, we just apply the root. And mean absolute error, instead of doing the square term, we just do that absolute. Okay, and we can do that mean absolute, the difference between the predicted and actual. Okay, so after that one, we can do that average of those things. So these are the parameters which can help you for whether your model is giving the good error, bad error, I mean the error is less or not. If the error is less, that means the model is good. And predictive power, how predictive power is the ability of the model to accurately predict the dependent variable with the new data. Okay,
And I have a question.
yep.
How are you gonna practice this? Are you gonna use any platform like Kaggle or something like that?
I would like to show you this everything by tomorrow's session. Okay, and here we have AAC and BAC values are there. So if AAC and BAC values, which is giving that if when we have the more complexity, okay, of in your model, then the lower AAC and BAC values, which indicating that the model is good, better model actually. So
Is there
these are
any way you
the,
can send the document, because I think going through it at least once will help before, to
sure.
really understand what's going on here.
Okay, sure. So I would like to upload this document in our Canvas, okay, playlist. Within that linear regression, in the documents, we have a document module is there. Within that one, I can upload it. Please go ahead with this document actually. So this document will help you to understand more. And nothing waste information is there. Everything is important only. I put everything here, important information, and it can help you even in interview point of time. Okay. So that's for today's session, guys. I just explained that only linear regression theoretical information. Okay, by tomorrow's session, we'll do a practical session actually on linear regression itself. Clear? Even I can spend some time on the multiple linear regression. See you guys. Bye. Take care.
Okay, thank you.
Anjan,
Yep.
what is the next session? Is it like Tableau or SQL or anything?
Ahmad and Shalini, you will get that my time slots of different okay modules, and based upon
Yeah,
your
I think
willingness, you can
I
come.
have it. I think I just saw I noted down for SQL and Tableau, so I can I think I have Asif's number. I'll share with them.
Okay, so I've just show you for my okay.
I think both of those are in the morning. I see it. I mean, our morning.
Not bad. See, this is the times you should follow it.
Oh, okay.
Okay, SQL it could be 8:30 p.m. IST. Tableau it could be 9:30 p.m. IST. IST means Indian Standard Time. Follow your time, convert into your specific timings. And in the morning IST, okay, machine learning and Python. Okay, so I was not done my old machine learning concepts, my old machine learning batch. So once it is done, then I can start the statistics. Okay, please take these time slots, and so based upon your willing time, you can come for the multiple models so that we can finish it as much of as possible. The reason is that from the February onwards, I'm not available. That's the reason I would like to finish it everything in a short term. Okay.
I mean, this one would continue into February, right? The ones the
Yeah, until
ML and the
unless
Python what you're teaching.
until unless I can finish this all models, I cannot stop anymore. Okay.
Oh, I got you. Yeah, yeah.
Once it is
Okay.
done, I cannot take the sessions. I cannot take the next batch actually. So from the next batch onwards, I was a little busy. Okay. So I have to
Okay.
finish it all the batches. So January or February time only. Okay. That's the
Okay.
reason
So
I try to be
so this
comfort.
ML and Python what you're teaching, you'd be finishing up in a month, which is about
Yeah.
towards Feb end, right? Okay.
Yeah, it's
I just
already
had a
7:30.
request. I
Yes,
just had a
Shalini,
quick request
Shalini
for.
is it's
Okay.
already
Okay.
7:30. My
Yeah.
another
Sure.
batch
Sure.
is
Yeah.
another batch
Sure.
students are
Thank
waiting,
you.
and
Yep.
we'll meet in a Python session. And if you have any doubts, we'll
Sure.
discuss about it.
Thank you.
Even Ahmad,
Thanks.
you also, okay?
Yep.
Okay.
And take the screenshot and try to be come for multiple sessions. Okay, whenever the free time we have it, then definitely we'll talk. Okay.
Okay.
Yep. Bye.